have seen this table now. Okay, the table number 12, bending moment coefficients. So you know that these are the coefficients for dead load, these are the coefficients for live load. So here what is the condition is given, here is the condition near the middle of end span. So at the middle of end span, what are the coefficients? Plus 1 by 12 and plus 1 by 10. Okay, so you note down these coefficients so that there is no need to every time we shall open the IS code. So here at the middle, what are the coefficients? It is 1 by 12 and 1 by 10, and both are plus. 1 by 12 and 1 by 10, both are plus. Then at the support next to end support. So at the support next to end support, okay, at the support next to end support, the coefficients are minus 1 by 10 and minus 1 by 9. So these are the coefficients. At support next to end support, these are the coefficients. And then these are the coefficients at support next to end support. And then at middle of interior span. Okay, so at the middle of interior span, so middle of interior span, the coefficients are 1 by 16 and 1 by 12. And after that, at other interior supports, now in this case interior support is present because it is 4 span continuous beam. So at interior support it is minus 1 by 12 and minus 1 by 9. So these are the values of the coefficients which we got from the table number 12. So now we will move to our numerical. So we will take the coefficients now. So the first our heading is here the bending moment calculation. Bending moment calculation. Now in this, first thing at where we are going to calculate at middle of end span. So we are going to calculate it at middle of the end span. So at the middle of the end span, so the coefficients are for dead load 1 by 12, for live load it is 1 by 10. So our formula will be 1 by 12 into WUD, that is dead load, into L effective square. Okay, so this is for dead load coefficient, plus we need to add the live load also in this, plus 1 by 12 is the coefficient for live load, it is WUL into L effective square. You have done this many of times. So now put the values and let me know the answer. You just put the values now. We are calculating at the middle of end span. Okay. So your end span is 4 meter. 145.8. It is the answer given by roll number 15. Okay. So don't give the answer privately. Make it public so that others can also verify the answers. Okay. So please check 145.8 is the right answer or wrong answer. Please check it. So if I put the values over here, here it is 1 by 12 into what was our dead load? Our dead load was 25.2. It is 25.2 into L effective square. So end span is there. What is the end span? It is 4 square. 4 meter is there. Plus then again 1 by 10 into live load. So live load it is given as 19.5. It is 19.5 into again 4 square. So if you do this calculation, the answer given by roll number 15, it is 145.8. Is it the right answer? Shall we go with this answer? Kilonewton meter. L effective span is 6 meter for intermediate. Intermediate spans are 6 meter. End spans are 4 meter. It is given in the problem. Please check the problem. Okay. So end spans are What is the answer? Someone is saying 64.8, then 33.6. Which one is correct? 64.8. Roll number 3, roll number 23, roll number 63 are getting 64.8. So shall we go with this 63.8? Is it right one? Okay, sorry, 64.8. Okay. So the answer is 64.8. हा हे बघा ही जी तुमची बीम आहे नाव ज्यांचा आन्सर चुकलाय त्यांनी बघा कुठं चुकलाय तुम्ही ते ही तुमची बीम आहे ओके आणि इथं हे सपोर्ट्स आहेत या बीमला दीज आर द सपोर्ट्स वन दिस इज युअर फर्स्ट स्पॅन दिस इज सेकंड स्पॅन third span and this is fourth span. This is your fourth span continuous beam and now they have given you that this span is 4 meter and this span is also 4 meter and these intermediate spans these are of 6 meters. Now where we are calculating the bending moment right now? So right now we are calculating the bending moment at middle of end span. Here we are calculating the bending moment. So end span. So this is our end span. This span, this is nothing but your end span. This is also your end span. Here, this is also your end span. So what is your end span? Your end span is 4 meter. That is why you should take here 4 meter. Okay, I hope now this is clear with you. Okay, so now this is at middle of end span. Now after middle of end span, the second thing we are going to calculate the bending moment, and we will calculate the bending moment at so at where at support next to end support at support next to end support. So here at support next to end support bending moment is equal to, so what will be the bending moment support at support next to end support? Our coefficient was minus 1 by 10 and minus 1 by 9. Here if I put minus 1 by 10 into WUD into L effective square plus here it is minus 1 by 9 into WUL into L effective square. Okay. So the bending moment is equal to, now it is minus 1 by 10 into minus 1 by 10 into our this thing. Dead load was 25.2 into 6 square plus here it is minus 1 by 9 into 19.5 into L effective is 6 square. So now here if you see here, now we are calculating the bending moment at this point. Here, this point or at this point you can see. This at these 2 points we are going to now calculating the bending moment. Bending moment at support next to end support. So this point is common for this span also and this span also. Similar is the case with this point. So we are going to consider the maximum span for this point. Okay. So we are going to consider the maximum span for this point, and the answer is 168.72. Others, please check the answer. So now, see for end span, you know the specific span, but for this point is common for this. If I say that this is span number 1, this is span number 2, then it is common point. So we are going with the maximum span. So the answer is minus 168.72. Okay, that is the correct answer. So the bending moment minus indicates that hogging minus 168.72 kilonewton meter. So if the minus sign is there, then this indicates as the hogging moment. Okay. and for positive sign indicates sagging moment. So now the next point is we are going to calculate the bending moment at middle of interior span. Okay. So the next is bending moment at middle of interior span. Okay, so third thing, bending moment at middle of interior span. Now you know the formula. I will directly put here the values of coefficients. So the bending moment is equal to, so the bending moment, the coefficients are we have already seen in the IS code. It is 1 by 16 and 1 by 12. Okay, so here this is 1 by 16 into our dead load is 25.2 into 6 square plus here the another coefficient is 1 by 12 into 19.5 into 6 square. Now if you solve this, you will get the value of bending moment. 115.2. Okay, 115.2 kilonewton meter is the right answer. So here the bending moment is equal to 115.2 kilonewton meter, and this is sagging moment because we are getting positive answer. Okay, and at the last, where we are going to calculate the moment. So at the interior support, at interior support, at interior supports we want the value of bending moment. So bending moment is equal to, the coefficients are minus 1 by 12 and minus 1 by 9. So it is minus 1 by 12 into 25.2 into, for interior span it is 6 meters, plus here it is minus 1 by 9 into 19.5 into 19.5 into again it is 6 square. So the bending moment is equal. So it is the hugging moment. So minus 153.6. So it is minus 153.6 kilonewton meter. So these are the values which we got now for the calculation. So if I show these values in the figure, okay. So now see at the interior support it is 153. Then bending moment, this moment 115. It is at middle of interior span. Okay. So here now if you see, if I project this diagram and if I draw only the bending moment shape of the diagram here. Now this is our diagram. Okay. So see this is your point A. Suppose this is point B, this is point C, this is point D, and this is point E. So I will mark the points over here. Point A, and at the last here is point E. In between points, here is somewhere point D is there. Here somewhere point C is there, and then here somewhere point B is there. Now, if I draw the bending moment curve, then the curve will be, it will go in this fashion. Now, if I tell you the values, okay, at the middle of end span, what is the value? 64.8. So here, this is the point. Here the value is 64.8. Here also the same value, 64.8. Okay, next value is here. At the support next to end support, it is minus 168.72. So at the support next to end support, this is the point at support next to end support. And this is the point at support next to end support. And what was the value? It is 168.72. So the value is here the value is 168.72. Here also the same value 168.72. Okay. The next what we have calculated at the middle of interior span. Okay. And at the middle of interior span the value is 115.2. So at the middle of interior span is this point. So this is your interior span. These two are the interior span and at the middle. So here the value is 115.2. Here it is also 115.2. Okay. And at the last, where we have calculated the moment. So at the last, we have calculated the moment at interior supports. So at the interior supports, it is 153.6. So if you see here, this is your interior support. This point here, your interior support is there. Here, your end support is there. So here at this point A, end support is there. At this point, at the point A and E, end supports are there. At the point B and D, your supports next to end supports are there. And at point C, interior support is there. So the value at the interior support, that value we have calculated that value as 153.6. So this value is 153.6. So this is our bending moment profile for this continuous beam, and we have evaluated the bending moment at every important point where we need the value of bending moment. Now we can say that these some values are plus and some values are minus. So this is plus, this value is minus, here it is plus, this is minus, this is plus, here it is again minus, and second here it is plus. So this is our bending moment diagram. Okay. Now we will take the check for depth for the maximum moment. So if you see which is the maximum moment, 168.72 is the maximum hogging moment, that is maximum negative moment, and 115.2 is the sagging moment, maximum sagging moment. Okay, so here I will take check for depth now. So the next point is check for depth. So to check the depth, we always equate our maximum bending moment to moment of resistance. Okay. So what is our maximum bending moment? It is 168.72 into 10 to the power 6 Newton mm, which is equal to Mr. Now grade of steel. Tie grade of steel 415 to 500. What grade of steel is given? Let me know the grade of steel. 415. Okay. So if 415 is there, then 0.138 FCK VD required square. Okay. So now this is the formula. So in this formula now we need to put the value. Okay. So I think we have assumed the value of B as 300. If we have not assumed the value of B as 300 previously, now assume the value. Okay, it doesn't matter. So you always assume the value of B as 230, 250, 300, 350. This is sufficient. 230 to 350, you can assume any value for B. So most of the time go for 230 or 300. So now, if you put the value of B, what is the answer? 68.72 into 10 to the power 6, which is equal to 0.138 FCK 20. B is 300 into B required square. So therefore, B required is equal to. So the value of B required it is 451 mm. Okay, 451.4. So it is 451 mm is the D required. And what D we have provided? What depth we have provided? 600 or what? 600 effective, no? Effective we have provided 600 and overall depth What was our overall depth? 640. Okay. So now D required is less than D provided. D required is less than D provided. Hence it is safe. Okay, so it is safe. So the provided depth is okay, it is safe. So now after taking a check for depth, we are going to calculate the speed. Okay. So what is our maximum positive moment and maximum negative moment? So maximum, I will call it as a sagging moment. Maximum sagging moment, that is maximum positive moment, and maximum hogging moment. Maximum hogging moment. So those values are, so our maximum sagging moment is 115.2 and 168.72. 115.2 and 168.72. Okay, kilonewton meter, kilonewton meter. These are the maximum sagging moment and maximum hogging moment. Okay. Now after this, we will do the steel calculation. Steel calculation. Now, what steel calculations we need to make? So first, for mu is equal to, first we will take this, okay, 168.72 kilonewton meter. So our formula for AST is equal to 0.5 FCK BD whole divided by Fy in bracket 1 minus under root 1 minus 4.6 mu divided by FCK BD square. So just put the values over here. AST is equal to, okay, 865.6. Is it the right answer? 865.6 mm square. All of you are getting the same answer. Please cross verify the answer. If the calculation gets wrong, then the whole problem will get wrong. Okay, correct answer. Okay. So now, next thing is that provide 20 mm. We have assumed 20 bar diameter. So calculate number of bars. Okay. So the number of bars is equal to 865.6 whole divided by 5 by 4 into 20 square. Let me know the answer. 2.75. Okay. 2.75, which is nearly equal to 3 numbers. So now calculate AST provided. Now calculate AST provided equal to 3 into 5 by 4 into 20 square. So the AST provided is 942.47. 942.47 mm square. Please check the value. So okay, it is correct answer. Okay. Now calculate the percentage of steel. So the percentage of steel, PT. PT is nothing but percentage of steel. So percentage of steel now. It is 100 into AST provided divided by BD. It is 100 AST upon BD. So what is the percentage of steel now? It is 100 into 942.47 whole divided by 300 into 600. So the percentage of steel is 0.52. Okay, so the percentage of steel is 0.52%. Now same thing we are doing for the calculating the AST for. Now this we have calculated for which moment? Negative moment. Correct. That is hogging moment. Similarly, we are going to calculate it for sagging moment. Okay. So for mu is equal to 115.2 kilonewton meter. Okay. For that now again use the formula of AST. AST is equal to I think you can now find the value. Is there any need to write the formula again? Now you know the formula. Just put the values. Put this moment only. There is change in the moment only in earlier formula here. We are having the formula in this formula only. Instead of this 168 now put 115.2. You will get the answer. Use this formula. Answer is 569.42. Please check the value. 569.42. 569.42 mm square is the answer. Okay. So is it right? Anybody has cross-checked the answer? Okay, right. Now again, now here it is 569. So instead of going for 20 mm bar diameter now, we can reduce the bar diameter up to 16 mm. But still, see what will happen. We will go with the same diameter, 20 mm bar diameter. Okay. Now calculate number of bars. Number of bars is equal to. So how many number of bars are there? So the total area of steel. What is 569.42? So the total area of steel is 569.42 whole divided by area of single bar, that is 5 by 4 into what square? 20 square. So the answer will be 1.81. So 2 bars we need to provide. And see that in a exam, suppose if you get the less answer, less number of bars, at least you should provide 2 bars, whatever may be the reinforcement. Okay. In this case now we have to check the minimum reinforcement, and the clause for minimum reinforcement, it says that is distribution steel clause, that we have to take the 0.15% for mild steel and 0.12% for torch steel. So here the answer is 1.81, which is nearly equal to 2 numbers. Okay. So these are the number of bars for which moment? For sagging moment. Okay. So at the bottom, okay, and at the top, that is for hogging moment. How many bars we have calculated? 3 number of bars. So we can summarize this. So I can write over here, provide 3 bars of 20 mm diameter at top and 2 bars of 20 mm diameter at bottom. 2 bars of 20 mm at bottom. Okay. Now after placing this main reinforcement, now the next point is shear reinforcement. The next point is shear reinforcement. Now how we are going to provide the shear reinforcement? So that is the most important thing. So for the shear reinforcement, you always remember for continuous beam and continuous slab, we always use table number 13. Okay, and you need to go to page number 36. We are always going to use this table number 13. Okay. So for this purpose now, first of all, we need to calculate the maximum shear force. Now here, if you look this diagram, which we have drawn previously, this diagram now. Okay, so this diagram over here. So the maximum shear force. Okay, so we need to find out where would be the maximum shear force. First of all, okay. So to calculate the maximum shear force now, in this now how many supports are there? 1, 2, 3, 4, 5. Among these 5 supports, there is one support or 2 supports are there where we are getting the maximum shear force. So that we need to calculate first. Okay. So for that, we should visit the we have to go to page number 36 of the IS code, and from on that page number, different coefficients are given. So accordingly, we will choose our coefficient. Okay. So we will complete that this remaining part in the next lecture. So now less than 1 minute is remaining. Fast enter your roll number into the chat box.